Okay, there are lots of ways where you can solve for the current across the inductor. And you can do the integral, right? I is equal to 1 over L times the integral of V. You could use the step equation. The way that I chose to do it was, I chose to do KCL at the top node and find I sub R. Well, this is the method I chose. I said, well, 160 milliamps is plus IR plus IC plus IL will equal 0. Therefore, IL will be actually it's going into the node, so it's negative 60. So it's going to be the negative of that, which is 160 milliamps minus IR plus IC. Okay. So I'm going to put that aside and come back to that. IL is minus 1 plus 160 milliamps minus IC plus IR. Okay, well, IR is super easy. We have V. V equals IR, so I is V over R. Just divide this through by R, and you should come up with VR is equal to, well, this is 125 ohms. So put that into your calculator, and where's VR? Okay, so I have IR is equal to 128 TE to the negative 800 T plus 0.16 E to the negative 800 T. I'm going to park that over here because we'll need it after we find the capacitor current. So we have IR is equal to 128 TE to the negative 800 T plus 0.16 E to the negative 800 T amps. Okay, that's parked there for now. The capacitor one is kind of a little bit more of a pain, but it's not too bad. So I sub C is going to be C dV dt. I'm going to park the capacitor for a little bit and just focus on dV dt. dV dt is going to be the derivative of this, which I'm going to do in green so that I don't confuse myself, and then the derivative of that, which I'll do in blue. So the derivative of this part, is going to be 16,000 times T times the derivative of e to the negative 800, and that's going to be negative 800 e to the negative 800 t. Okay, and then it's going to be this times the derivative of t. Well, the derivative of t is just 1, so we just need to bring it down. Okay, so plus e to the negative 800 t. I'm going to distribute my 16,000 all the way in, and that gives me, this is negative 12 million, negative 12 times 10 to the 6 t e to the negative 800 t, and then plus 16,000 e to the minus 800 t. That was this part of the equation. Now I need this part of the equation. Well, that part is pretty easy. The derivative of 20e to the negative 800t is just going to be negative 800 times 20 times e to the negative 800t. Negative 800 times 20 is going to be negative 16,000. So we have a positive 16,000 e to the 800t minus 16,000 e to the 800t, and that is 0. So we have then dV dt is simply this value here, negative 12 times 10 to the 6th te to the negative 800t. So let's put that in here. We have 5 microhenries, or microfarads, times 12 times 10 to the 6th te to the minus 800t. Amps is the unit. And when you multiply that out, you should get that I sub c is, oops, I lost my negative. I sub c is negative 64 te to the negative 800t. Let's park that over here. I sub c is equal to negative 64 te to the negative 800t. Okay. So what did we say over here? We said that I sub L will equal 160 milliamps minus IC plus IR. So let's compute IC plus IR. IC plus IR is equal to, let's take the IC first, minus 64 te to the negative 800t. And now the IR, add the IR to it, plus 128 te to the negative 800t plus 0.16 e to the negative 800t. And we see these two terms combined. 128 minus 64 is 64, positive 64. 64 te to the negative 800t plus 0.16 e to the negative 800t amps. Okay. So we solved that. Now we can put this identity that we just found, put that back in there. And so we have IL then, therefore IL will equal 160 milliamps minus this. We have this in amps, so we need to convert it into milliamps to match this. Minus 64,000 te to the minus 800t plus 160 e to the negative 800t milliamps. And so our inductor current equation will be 160 milliamps minus 64,000 te to the negative 800t plus 160 e to the negative 800t. And that is the answer to the second part of this problem. And it's a good idea to, hold on, let me see if I have it. Oops, I forgot a minus sign here. Minus. It's a good idea to just kind of do a check to make sure that the equation makes sense. So we said earlier that at time equals 0, there was no current through the inductor. So if our general equation fails that test, then it's a wrong equation. So at time 0, we have 160 milliamps times 0. This term goes to 0. This term minus 160 goes to 800 times 0 e to the 0 is 1. So we'll have 160 minus 160. And so it does at time 0, we do have I L sub t is equal to 0. So it makes sense with our initial condition. Okay, and that was the solution to the problem. If it helped you, make sure you give me a like, subscribe to the channel, and give me a shout out. Or if I make mistakes, make sure you let me know in a nice way. And I would really love it if the comments place became a place where people all over the world help each other learn the art of electric circuits. Thanks for watching.